Okay, today I'm going to look at multiplying mixed numbers using an area model, and we are going to call this part 1 because there are two ways that this can be approached, and in this video we are going to look at one of them. So what I have here is a gridded sheet of paper, and on that paper is a problem that we are going to try and solve using an area model. This particular one shows 3 2/3 times 2 1/4. So we are going to attempt to solve that using an area model. One of the things that we need to understand as we do this is that I've got two little arrows up in the corner. As I go to the right, across the page, each one of these grids is going to represent 1/3. And I get that because my fraction part that I'm using here is in thirds. Okay? So if I want to represent 3 2/3, I go 3 spaces to represent 1, 3 more to represent 2, because 3/3 is 1, 6/3 is 2, 9/3 is 3, and I need to go 2/3 beyond that. So this top line represents 3 2/3. Now as I go down, I'm going to use this as my basis for each square in the grid, or each line that I drop down. Each one is going to represent 1/4. Okay, so as I go down, I have to go down 4 spaces. 1, 2, 3, 4. That represents 4/4. 1, 2, 3, 4. That represents 8/4. So I've got my 2, and I'm going to go 1/4 beyond that. Okay, so this line represents 2 1/4. Now to solve this as an area model, what I want to do is I want to complete the rectangle. Okay, so I'm just going to go across here, open that up a little bit, and then I'm going to come down. Okay, and what I have is a rectangle that I can use to compute the area for this particular problem. Now, one method for doing this, and the reason I chose a grid for this particular one, okay, one of the things I can do is I can just count the squares. Okay, so I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 squares going across. And going down, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9. So I know that I have a total of 11 times 9, or 99 boxes inside of my rectangle that's going to represent the area. Now the thing I need to do to finish this up is to understand that each box does not represent one whole. Okay, because 3 2/3 times 2 1/4, obviously the answer is not going to be 99. What is the size of each box? What is the area of each one of these individual squares that are currently in here? And that answer I will find right here. Okay, because each square is 1/3 by 1/4. So each square represents an area of 1/12. And that's the final piece to my puzzle. The answer is 99/12. And this is the same answer that we would arrive at if we were just to take both of those fractions and change them into improper fractions. So 3 2/3, okay, is equal to, like I said before, every time we get 3/3, we get 1. So there's 2, there's 3, and I had 2/3. Okay, 3 2/3 is equal to 1, 2, 3, 2/3. 3, 6, 9, 10, 11. That's the number that we had up here, so it was 11 across. Okay. And if we look at the second one, 2 1/4 is equal to 4/4 plus 4/4. There's 1 plus 2, and an additional 1/4, and there I get my 9. Okay, so this is equal to 9/4, and that's where I get my 9 going down. Okay, so 3 times 3 gives me my whole number. 3/3 3 times, plus 2 is 11. 2/4 4 times is 8, plus 1 is 9, so there's my 9, and my denominator I get, because I'm looking at 11/3 times 9/4. Okay, and I get 99/12. And I can quickly change that from an improper fraction into a mixed number. All I have to do is divide 99 by 12. And 12 times 8 is 96. So that will leave me with a remainder of 3. So 99/12 gives me 8 whole units and 3/12. So now I know my answer is equal to 8 and 3/12. And 3/12 can be reduced if I choose to. 3 divided by 3 is 1. 12 divided by 3 is 4. So my final answer, 8 and 1/4.